Hello everyone, this video will show you some basics of using Matlab. Let's first open Matlab. Matlab can be used as a programming language that performs powerful scientific computations. It can also be used as a computer algebra system, which is the feature we will be using in Calculus 3. The interface contains several parts: the toolbar, the current folder, the workspace, and the command window. The current folder is the folder in which you will create, open, or save your files in Matlab. Click this button to change your current folder. I will choose the test Matlab folder. Usually you will see the list of files in this folder. My folder does not have any files, so it is empty. The workspace contains the variables you have defined in the current session. The session ends when you close Matlab. In the command window, you can perform simple computations or define variables. Let's define some variables. A equals 1, B equals 3, C equals A plus B, which is 4. Now you can see in the workspace, it displays the 3 variables we just defined, A, B, and C. You can define a row vector T from 1 to 2 with subinterval 0.1 by typing 1 colon 0.1, which is the length of the subinterval, colon 2. This defines a row vector with 1 row, 11 columns. If you press the upper arrow on your keyboard, Matlab will show you the command history, the command you did just now. So we will choose the previous one. You can scroll up and down to choose the one that you want. Now I will choose the previous command and add a semicolon. This way, Matlab does not display the variable for you, so the command window is clearer. Let's define another variable y that gives the sign value of t. Y equals sine t, and we add a semicolon so it doesn't display. But you can see that in the workspace, the variable y is still there, right? It is also a row vector with 1 row, 11 columns, and each one is the value of sine of the corresponding t values. If you double click the y variable in the workspace, it will display in another window the y variables. Let me close that. And now let's plot the function sine of t, where the horizontal axis should be t and the vertical axis is y. So plot function, notice that the plot function has 2 variables, t. T is the horizontal axis and y is the vertical axis. Then a figure window appears. Matlab will plot the 11 points you specified and connect them as line segments. Matlab also treats multiplication as matrix multiplication. You might not be familiar with this if you have not had linear algebra, but it means you cannot multiply a row vector with a row vector. Their dimensions do not agree. Multiplying a row vector by a column vector gives the dot product. If you want to multiply 2 row vectors element-wise, you need to use a dot to multiply. So for example, suppose we want to plot the function y equals t times sine t. Let's type y equals t times sine of t and see what happens. An error message appears, right? It says incorrect dimensions for matrix multiplication. So instead of this, we will add a dot in front of the multiplication sign. Let's add a semicolon so it doesn't display numbers. This defines y as t times sine t. And we can plot it again, ty. Adding semicolon or not doesn't matter because this doesn't have any variables defined. Now, if you go to that figure window, the graph is now the graph of function t times sine t. It works the same way for powers and divisions. For example, if we want to find the function t squared, we cannot do t squared directly because t is a row vector. When you do t squared, you are multiplying two row vectors together. So instead, we add a dot before the power sign. Division, let's try 1t, divide by, again, we want the division to be element-wise, so exp. Here, exp of t means e to the t's. Matlab contains most of the common functions with their regular names. One exception is that log t, the log-t, means natural logarithm. Let's now look at the different files in Matlab. You can click this button, Save Workspace, to save this workspace, all the variables in a file. So let's click that. And let me name it as Matlab Intro. Notice that the file extension is MAT. That's the data file of Matlab. So save it in our current folder. You can see this file in the current folder window. So next time if you closed your window, if you closed Matlab and reopen it, you still want these variables, then you can double click this file, Matlab Intro, double click, or you can just type load file name in the command window. Then all the variables will be in the workspace. Okay, now if you click the arrow below the new button here, you will see a list of files that Matlab can do. I will only explain the first three, which are the ones I have used. So a script file consists of a group of command lines. If you save this file in your current folder and type the name of this file in the command line, all commands in this file will be executed. Its extension is .m. A function is just a function. It is a program. It has input parameters and output parameters. Again, you save it in the current folder and run it in the command line with input parameters specified, then it outputs the result you want. The live script file is the one we will be using a lot in this course. So let's create one live script file. We click the live script button and a new window opens. This is the Matlab editor. You can see there are two columns. You type your command in the left column, the result displays in the right column. Let's type some command. So this time I will still do a vector, define a vector t. This time I want it to be from 0 to pi, 0, colon. I want it to be to pi, and I want 20 subintervals. That means the length of each subinterval will be pi over 20, right? Here, the lowercase pi is the built-in value for the value pi. So semicolon so it doesn't display. And we will let y be t times dot times sine of t. We will then plot function. And I will explain some other parameters here. By default, the line segment is blue. And this time we want it to be red. And we don't want the line segments. We want star for each data value. So now, if you move your cursor to the left of this gray box area, this is called a section. If you move your cursor to the left, a blue bar will appear. That blue bar means you can click it to run the group of commands here. So click that blue bar. The right column now will display the result. Okay, so you can see that we have 20 intervals, 21 points, and the 21 points are represented by red stars. Okay, so let's now look at some of the buttons here. The text, code, and section break buttons make the grouping easier. Put your cursor, for example, at the beginning of this section and click the text button. You can see a blank line appears where you can type your title or notes here. Say plotting single variable function numerically, which means it will plot the points you specified. Now, if we put our cursor at the end of the section and click section break, it will then give us a start a new section. So now let's type another group of commands here. So far, we have been doing numerically plotting functions, which means we specify certain points on a graph and let Matlab plot the points and connect them. So instead of numerically plotting graphs, we can also do it symbolically. So let's define a symbolic function, f equals. To define symbolic function, we use at parenthesis x. This indicates the variable. You can put x there, you can put t there. You can use x comma y to indicate two variables. Here, let's do x times sine x. So the same function. And symbolic plotting, you should use the command fplot. And this time, we only need to type a f here. If you don't specify the range, then Matlab will automatically choose the range for you. In our case, I want the range to be 0 to pi. Let me also put a colon. So now you can see that when you put the cursor to the left, the blue bar appears only for the current gray section. So when you click that, it will only run the two lines you typed here. Okay, so you can see the result on the right. Another thing is you can add a comment in the command lines using a percentage sign. Let's say plot between 0 and pi. That's the comment. Here we have a warning sign, right? Here is a warning sign, and there is a warning here saying that function behaves unexpectedly on array input. To improve performance, properly vectorize your function. This just says that we still have that inconsistency of dimension. So let's put a dot to avoid that. And let's run this part again. You can see that the warning disappears. And we can click Save here to save this as an MLX file. Click Save, and I'll name it as Matlab Intro. And this time, the extension will be MLX. That's the extension for live script file. You can see here. Okay. I hope this is helpful. Please practice the commands we have learned in this video and the ones I posted in Canvas.